In this video, we're just going to talk about some useful little tips that you may need as you write your own proofs. So these aren't going to be full proofs. They're just going to be little things that will be helpful as you go. So in this first example, we're not given anything. Actually, we don't have any given statements, but we've got two triangles here. There's this triangle on the top, A, D, B, and this triangle on the bottom, B, C, D. And even though we're not given any statements, we still can say something about these triangles, because note that they share this side here. Side BD is in both triangles. Therefore, in a proof, we could make a statement like this. BD is congruent to BD. Now, it sounds kind of obvious. Of course, BD is congruent to itself. But why would you need that? You would need that if, let's say, you were trying to use the side-side-side postulate or hypotenuse leg theorem, anything like that, where you need to have a statement that these two sides are congruent in order to therefore say that the triangles are congruent, in order to use one of those postulates or theorems. So you need to say that in the proof, and then you need a reason for that. So what is our reason? Our reason is simply called the reflexive property. The reflexive property is what you will use anytime you have shapes that share a side like this, and it just allows you to make that statement in your proof. Therefore, you can go on to say anything that requires those two sides to be congruent. Let's look at another example. Here, we're given one statement. We're given that DC is perpendicular to BC. So that is in this triangle on the bottom here. And what do we know about perpendicular lines? It's kind of given by the perpendicular symbol here. They form a right angle. So this angle here is 90 degrees, and that is going to be useful in a proof. And so the way you would show that in a proof is just like this. You would use your given statement first. DC is perpendicular to BC. And then you could say angle C is a right angle. And the reason for that is what we know, the definition of perpendicular lines. So any definitions that we know, like definition of parallel lines, perpendicular lines, angle bisectors, anything like that, we can use in a proof. And the reason is just the definition. Same thing with the definition of midpoint, which we've used in some of the earlier examples. Last up, we're going to look at a couple of angles that are congruent. So here we've got two congruent angles in these two triangles. So the first set are A and C. Those are marked in orange. Then we've got ADB and CBD. Those are marked in green. And now what else can we say based on those two statements? So if we know that two angles in a triangle are congruent, then we can say that the third angles are congruent. So those are the ones marked in red here. Now why? Why is that okay? Well, think about what you know if you know two angles of a triangle. Let's say that the triangle, the angles that we knew were 60 degrees and 60 degrees. What would the missing angle be? Well, it would have to be 60 degrees because the sum of the interior angles of a triangle is always 180 degrees. If you had, in this example, it looks like angle A is about 90 degrees, looks like a right angle. Let's say angle ADB was, let's say 30 degrees. So if this is 30 and this one is 90, then what is this one, the missing one? Well, 90 plus 30 equals 120, and 180 minus 120 is 60. That means that this angle is 60. And since we know that angle A and C are the same, this one would be 90, and this one would be 30. And again, I'm just making up these numbers for the sake of the example. And the same thing is going to be true here. This one is going to be 60. And so we just showed that the missing angle must be congruent. So how do we show that in a proof? Well, it looks like this. We do our given statements right there. And then our third angle, ABD and CDB. And why can we say that? And that is just another definition from geometry, the sum of the interior angles of a triangle. We know the sum of the interior angles of a triangle are always 180. So we can just say that in the proof to prove that those third angles are congruent.